We continue with probability. What is the probability of getting either a club or an ace when drawing a single card from a deck of 52 cards? So this is an OR probability. So we add the probability of each event and then we subtract the probability of their intersection. So the probability that we want to find of either club or ace will be the sum probability of club plus probability of ace minus probability of the intersection of these two events. Ace, which is club at the same time. So probability of club. There are 4 kinds of cards and club is one of them. So there are 13 cards from 52 which are club. So we will leave this fraction not simplified since we will add another fractions with the same denominator 52. So then probability of getting an ace, there are 4 ace from 52 cards minus probability of both ace and club. So there's one ace from 4 which is club, so one card which is both 1 over 52. So we have 3 fractions with the same denominator 52. 13 plus 4 minus 1. 13 plus 3 will be 16 over 52, and both numerator and denominator are divisible by 4, divide by 4, we'll get 4 over 13. Consider a game in which a player rolls one die. If an even number comes up, the player wins a number of dollars showing on the die. If an odd number comes up, the player loses the number of dollars showing on the die. We want to know the expected value for the game, and we assume that no cost is paid to play the game. So we have 6 different situations, and so we have 6 different numbers possible on the die. So probability of each outcome is 1/6, and let us list them all. So if 1 comes up, the probability is 1 over 6, and the player is an odd number, so we have either odd or even. So odd number, the player loses the number of dollars, so it is multiplied by -1. Then if 2 comes up, an even number, the probability of 2 is also 1/6, but the player wins $2. Then 3 comes up, probability is 1/6, the player loses $3, probability 1/6, the next outcome is 4, even number, winning, plus $4. Next situation, 5, odd number, so he loses $5. And the last situation, 6, probability is the same, 1/6, and even number means winning, plus $6. Let us add all these fractions. All fractions have the same denominator, 6. So we have -1 plus 2 minus 3 plus 4 minus 5 plus 6. So 1, 1, 1, 3 over 6, or 1/2, or 50 cent. So positive 50 cent is a good play, but the game is not fair. The expected value is 50 cents, and the game is not fair. Let us consider another game. The card is drawn from a standard 52 card deck. So this time the player must pay $10 to play. So $10 must be subtracted from the winnings. So if a heart is drawn, the player wins $22. Otherwise, they lose their $10. So we have the probability 1/4, since the hearts are represent 1/4 of the card deck. The probability is 1/4 to get a heart. Then the player gets 23 minus $10. Another situation is any other card. The probability of getting any other card is 3/4, and then the player loses $10. So we have two fractions with the denominator 4. 23 minus 10, 13, minus 3 times 10, minus 30. Yeah, so negative 17 over 4, or negative 4 1/4 of 4.25. This is the expected value of the game, negative 4.25. To find the fair price, you should find the difference between the price that is paid for the game, 10, and this unfair price. 4 minus 4.25 will be 5.75. The game must cost $5.75, then it will be fair. Price for fair game. And the last chapter 14, statistics. Let us find mean, median, and mode for the following distribution. So I removed the last numbers, so it will be too long. So we want to find mean. We add these two numbers, find the sum, and divide by the number of numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 11 numbers here in the set. So to find mean, we add them up, 84, and divide by 11. So 7.63, 63, 63, and so on will be approximately 7.64. So since the next number is 6, is rounded up. Median. To find median, we first have to rewrite this set in the descending or increasing order. So be careful, don't skip any number. So 2, 3, 7, 7, 7. We have 3, 7, 8, 9, 8, 9. We have also another 9, then 10 and 11. Let us check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, it must be 11. I skipped somebody. There is another 11 here. So another 11. Now there are 11 numbers, and we can find the median this time. So 5 to the left, 5 to the right, 8 is in the middle. so median is 8. Mode is the number that occurs the most often here. So actually we have 2 9s, 2 11s, but 7 is 3 times, so the mode is 7. Find the range, mean, the standard deviation of the data set. So the range is the difference between the largest number and the smallest number. Is 16 minus 5, 11. So this set is already organized in increasing order. The mean is, so it's not, so for mean it's not important that it's organized. We must add them up. 5 plus 9 plus 10 plus 12 plus 14 plus 16 and divide by 100 by 6. It will be mean, and this is also 11, 66 over 6. Then we want to find standard deviation. Standard deviation. For this purpose, we subtract mean from every number and square. 5 minus 11 squared plus 9 minus 11 squared plus 10 minus 11 squared plus 12 minus 11 squared plus 14 minus 11 squared plus 16 minus 11 squared. So 5 minus 11, 6 squared. All this is negative. When squared, negative sign disappeared, so 6 squared, 36, plus negative 2 squared, or 2 squared is 4, plus 1 plus 1 plus 3 squared is 9, plus 16 minus 11, 5, 5 squared, 25, which is together 76. So standard deviation will be the square root of this sum, 79, divided by, don't forget, not n, not 6, but 6 minus 1 divided by 5. Oh, sorry, not 6, 76. So, and this fraction will be 15.2, and square root is approximately 3.8987. We want to have 2 decimal places, so we round. If we have 8 here, round up will be 10, so must change to 9. 3.90 or 3.9 is the standard deviation. And another set of problem works with this interesting rule, 68, 95, 99.7 rule. We deal with normal distribution. Normal distribution has such a bell form with the center at mean. So, and we know that at the point 1 standard deviation from the mean, 68% of data values happen to be here inside this region. So for our distribution, the mean is 4 and standard deviation is 1. So this is 4 plus 1 standard deviation will be 5 plus 2 standard deviation will be 6. So, and 3 standard deviation will be 7. And to the left here will be 3, 2, and 1. So the percentage, we are interested in percentage of value in between 4 and 5. So what is the percentage of values between 4 and 5? between 3 and 5, we have 68% of data values. So the normal distribution is symmetric. So here will be half of them, 68 over 2, 34% of data value will be between 4 and 5. In the next example, standard normal distribution has mean of 17 and standard deviation 4. So it means that, let us add 4 plus 4 will be 21 plus another 4, 25 plus another 4, 29. So here's the mean, minus 4, 13, another time minus 4, 9. So this bell form is symmetric. So here are 68% between 9 and 25, 95%, and minus another 4 will be 5, between 5 and 90 in 29, 99.7% data values. Find the percentage of values that lie above 29. Oh, very small number. So don't forget the distribution is symmetric. Between 5 and 29, 3 standard deviation to the left and 3 standard deviation to the right, there are 99.7% of values. So it means that the rest is below 5 or above 29. Below 5 and above 29 are equal groups, equal number of values. So we need to subtract 99.7 from 100 and divide by 2 to get the answer. So 100 minus 99 will be 1, 1 minus 0.7 will be 0.3, 0.3 divided by 2 will be 0.15%. 0.15% of data values. One more example, the same rule. The mean is 11, standard deviation 3. So plus 3 will be 14, plus 3, 17, minus 3, one standard deviation will be 8, minus 3, 5, so mean is here. Find percentage of values that lie below 8. So between 8 and 14, so not symmetric, 68% within one standard deviation from the mean. So the rest is outside. So we subtract 100 minus 68 and divide by 2. So when we subtract, we get this plus this, and we need 1/2 of them. 1/2 of them. So 100 minus 68 will be 32%, divided by 2 will be 16%. 16% of data value lie below 8.